What do you notice about these two lines? Oh, they cross. What do we call that? Perpendicular. No, when they cross each other. Ooh, they intersect. So if we have lines in the coordinate plane, then this is some like XY coordinate, right? Yeah. Okay. Tell me something about this XY coordinate. Colin.
That it's going to be negative.
No, it's not. So if this is my y-axis and this is my x-axis, this would be the first quadrant. Okay, but I don't even care about the quadrant. Like I might even just like erase those. Tell me something about this coordinate. Necessarily. Yep. How is this point different than the green one? Yes. Okay. What does that red point have in common? True. Oh, both lines have this red coordinate. Do both lines have this green coordinate?
No.
No. Do you think that's special?
Yes.
Okay. So I want you to think back to when we graphed lines and we like plotted like the little like XY tables. Okay. If this was an actual like 3,4, what, and we had like the equation for this line, what could I do with 3,4, Colin?
You can depending, you can
Not really sure what the words were.
Yeah.
Okay. So if we have an equation and I have this coordinate, what does the coordinate do in the equation? It does serve a purpose, like a purpose that makes it equal, a purpose that doesn't make it equal. Name me a coordinate that is on this line. -3 what? -3, 0, right? Mm-hmm. Okay. What happens when I plug this point up here? I plug -3 in for X and 0 in for Y. What happens?
The coordinate and the y-intercept.
Like it works, right?
Yeah.
Okay. Here's another coordinate. 1, 4. What happens when I plug it in? 1 + 3 = 4.
Oh my gosh.
That's crazy.
Okay, so every single coordinate that I pick, what's going to happen when I plug it in? It's going to be a true statement. Okay, so let's come back to this picture. This XY coordinate. Tell me something about it. Thank you.
Yeah, okay.
If I plug XY into line 1, will it work?
Yeah.
If I plug XY into line 2, will it work?
Yeah. Maybe. No.
Yes, it's on both of them. That's what you did in your homework last night.
What?
Yeah, that was your homework last night. Okay. Go ahead and turn to page 134. Okay, we are going to start one of my favorite chapters, systems of equations. 134. Systems of linear equations. I'm going to give you a set of linear equations. And we are going to figure out the solution to a set of linear equations. Well, what the heck is a linear equation? What does a linear equation make? A line. So when I say a set, how many am I going to give you?
One.
More than one. I'm going to give you two. Okay. And if I give you two lines and I'm asking for a solution, what do you think I'm asking for? Where they intersect. Okay. So the solution is a point satisfies each equation, aka the intersection.
Look how we did it this, I guess, if you were to put two lines, they
Okay, so they gave you like two equations and a point. If you graphed those two equations, that point is where they intersect, which is what we are going to do today. So in your homework, you just like tested. Did they work in both of them? Yes or no? Okay. Well, today we're actually going to find it. Okay. So we're actually going to graph and find the intersection point. And where those two lines intersect, that is our solution, because that one point is going to work in both linear equations. Okay. So this is what's going to happen. All right. When I ask you to graph to find the solution, you're going to graph. You're going to figure out the point of intersection, but you always, I repeat, you always will check your answer. How do you check your answer? You do what you did last night. You plug it into both equations to make sure it actually works in both. Oh, dear heavens. It's gonna be great. Okay. So how about you look over at number 7 on page 135? Well, look at that. They've already graphed it for you, right? That was so nice of them. Okay, where do these two lines intersect? 2, -2. Label it. It's important. Okay, but we need to make sure that that actually is true. Okay, the thing about graphing is sometimes, especially like if you don't have a ruler, our lines might not be like super great. Okay, so we need to be careful. We need to always check. So let's come up here. Let's check. Our first equation, 3x minus 2y equals 10. So if I plug in the coordinate 2, -2 to 3x minus 2y equals 10, what do you think? Does it work? Is 6 plus 4 equal to 10?
Yes.
Okay, so it works in the first line. I'll go ahead and check that off. Okay. Now let's check it in the second line. How about I do it in pink? Sure. X plus y equals 0. X plus y equals 0. Is that true?
yes.
Okay. So our answer is the coordinate 2, -2. And I need you to write it in coordinate form. Don't say x equals 2, y equals -2. Give me the coordinate 2, -2. Okay. All right. Find me the solution for number 8 and check your answer. Find me the solution for number 8 and check your answer. Colin, where do these two lines intersect?
-1, -3.
-1, -3. Okay. Elliot, did -1, -3 work in this first equation? Okay. -1 minus 2 times -3 equals 5. Okay. Reagan, does -1, -3 work in the second equation?
Yes.
Okay. All right, well, that was nice because they graphed them for us. Okay. Let's go ahead and do the graphing ourselves. So go ahead and turn to the next page, and we're going to look at, can't remember which one I wanted to look at first. Look at number 10. Okay, now number 10, what form are both of these linear equations in? Ah, that's nice. Y equals mx plus b. Okay, so I'm going to graph this first one in orange. Okay. The y-intercept. Estelle, what's the y-intercept for this orange line? Mm-hmm. It is 3. Okay. And then what's our slope? Never mind. -1. Okay. A negative slope, remember, means we need to fall. Okay, so our rise over run is 1/1, but we need to make sure that our line falls from left to right. Okay, I'm going to do the second one in pink. Right? Amy, what's our y-intercept for the second line? 5. Okay. And then Maddie, what's our slope?
1.
Our slope is 1. So our rise over run, our rise over run is 1/1. Okay. Up 1/1, up 1/1. Now, some of you might want to use a straight edge to draw your lines. It's fine. Okay. I have rulers if you ever feel like you need to grab a ruler, or maybe like you have like an ID card that you can use when you're at home. Okay. But where do these look like they're intersecting at? Gavin, what does it look like? It really looks like they're intersecting at -1, 4. Okay. We need to make sure that that is actually true. We need to plug that point into both to make sure that in fact is where they're intersecting. So let's try it. If I plug in my coordinate -1, 4, does negative times -1 plus 3 actually equal 4? Yeah. Because that's really 1 plus 3, right? Okay. Let's try it in this one. Y equals x plus 5. So x plus 5 equals y. Does -1 plus 5 equal 4? Yeah, okay. Okay, so there's our solution, -1, 4. So 5 is our intercept, so we have to plot the point there.
Oh.
Then from there, we go up 1 over. Does that make sense? Okay, so what I'm gonna have you do, you have a new elbow partner. If you don't already know their name, please introduce yourself. I want you two to work through number 11. I know, it's fine. You and Carter. You and Carter can. Okay, so number 11, go.
Oh, wait, no, I have that one.
We do have one. Go down 1, 2. That's what I'm on.
Yeah.
Hey, does it feel like a cut? Does it feel like we learned anything new today? It does?
But then I watched times 2.
You didn't know how to grab one?
Oh my gosh, I like do these types of problems.
We have to do how to grab one.
Yeah.
So now we're grabbing the one.
Sophia.
We're looking back on our.
Yeah.
My number 11.
Is this what your 2 lines look like?
Yes. Precisely correct.
Okay, so let's talk about these graphs. So here I have a slope of 1/2 and a y-intercept of 2. So here's my y-intercept of 2, up 1 over 1 for my slope. So there's that red line is the first one. Okay. The second one, we have a y-intercept of 4, but a slope of -1/2. So I went down 1, right 2. Man, that's nice.
Oh.
Amelia, what coordinate did you name their intersection? 2, 3. Preston, does 2, 3 satisfy the first equation? If I plug in 2 for x and 3 for y, is 1/2 times 2 plus 2 equal to 3? Yes. Okay, if we put it in the second one, -1/2 times 2 plus 4, does that equal 3? Sure does. Do you have a question? Okay. All right. So I want to make sure that you do not forget how to graph lines that are not in slope intercept form. Oh, dear heavens. Okay, so let's talk about this guy right here. What form is this in? Do you remember that? Not slope intercept form, it's
Slope form.
standard form. Standard form, okay? I don't really like,
Didn't we do like something?
Yeah.
so you had some problems in standard form and you had to rearrange them to y-intercept form to figure out the slope. Technically, you could do that. Or I want to remind you of another method that we have. So option number one, you could solve for y. You could do some algebra and solve for y so it looks like y equals mx plus b. Option two, you can use the intercept method. If we plug a 0 in for x, what's our y-intercept? Negative 2y equals 6. Mhm. Y would equal negative 3. Because I would have 0 minus 2y equals 6. This was the intercepts. Finding the intercepts. Okay, so negative 2y equals 6, which means y equals negative 3. Okay, so there's my y-intercept. Then we could plug 0 in for y. What do we get for x? So that's our x-intercept, and then we connected the dots. We did this. We did this. So if it's in standard form, you have two options. You can find the intercepts, or I could have solved for y to figure out my y equals mx plus b form. Okay. Ooh, y equals negative 3. That looks like. It is not a dot. It is a horizontal line at y equals negative 3. If there's a vertical line, what kind of equation is it going to be? X equals a number is a vertical line. Y equals number is a horizontal line. Peyton, did you have a question? Is that you? Okay. All right. Well, Peyton, since I have your attention, what point of intersection do we have? 0, negative 3. Okay. Let's check. If I plug 0 and negative 3 into the first one, is 0 plus 6 equal to 6? Yeah. What if I plug 0, negative 3 into the second one? Well, there's no x, so I just need to plug y in. Does that work? Okay, that's good. Okay, so here's the deal. You know how to graph lines. I'm asking you to graph 2 lines at once and tell me where they meet. That's it. Isn't that great? So, yeah, that's how we're doing. So I have something for you.